Hi guys, Glader here, and today I have another video about GGDBF, and in fact, it's finally working. I'm probably going to publish the first version ever of this library, and I wanted to show you guys what it does and how it works, and, well, you've probably been wondering, for those of you who've watched the most recent videos, what the heck is this thing? Why do I need it? What does it actually do? Well, now that it works, I can give you a more full overview of what the library does. So, the library takes data models annotated with the system data annotations namespace. I think that's it. But basically, this is the attributes that you use on stuff like Entity Framework models. This works with Entity Framework, but it could work with anything that uses these attributes. What it does is you can create a partial test context, a data context, if you will, and mark it with the attributes of the models that you wish for this context to provide access to with these attributes. Once you've marked these models, which I'll go ahead and show you one, for those of you familiar with Entity Framework, you'll notice these. And this is very common. You might have a foreign key, you might have a primary key, and you might have a table name. To support this library, you must mark data members on each field that should be serialized, and any foreign key navigation properties should be marked with an ignore. It must have a table name, it must be unsealed, and all foreign key references must be virtual. Once you have this and you've included the GGDBF compiler library through NuGet, you can actually then compile and interweaved into the code using C#9 source generators. You'll notice that this code that I'm about to show you that it spits out for debug purposes is actually in your code. Pretty cool new feature from Microsoft, although I must admit I need some polish from them. It's very hard to use. So these things you generally would never see in your project. They won't appear unless you put some very specific things in your CSproj file to spit them out for testing. These are excluded from compilation, but the actual files are in. They're compiled. This data is compiled in to the assembly, but you won't normally see this. So let's take a look and see what it does for our test context. It generates an interface for the context. Additionally, it generates properties to provide read-only access through the simple primary keys. Right now it only supports simple primary keys to the data. It even supports generic model types. And it'll also spit out an initialized method. You plug in a data source and it's going to try to load that data. You don't have to use it as a singleton, but, well, that's really the only way to load it currently, is to initialize the singleton. And the reason for that is I'll show you. We want to take a look at one of these serializable types that it spits out. For simple types, such as test model type, this will not require an additional derived type to serialize. It's simple. But type 3, for example, has a foreign key reference. All foreign key references require a generated serializable model. And this overrides the virtual foreign key property. It is still serializable, and it accesses the static singleton instance of the data context and looks up the model with the key. And this allows for navigation properties to function within GGDBF, which is pretty cool. And it also supports collection properties. It is much more complex, but it emits a field that is a serializable collection of the primary keys to the other table. Then when accessing it, it will attempt to load this data in an incredibly efficient manner. There's no large allocation here or anything. You can call this and it's just fine. And it'll provide a collection to the foreign key references. Of course, this initialize is not called at runtime. This is called at generation time, when the data is generated, not at runtime when the data is loaded. So this performance isn't something you need to worry about, and this is not called. And another thing that we were able to support in the end, we want to go back to this test context file, was I really wished, and I didn't think it was going to be possible, but I really wished we could have open generic model types. Open generic model types with generic contexts. So you don't know exactly what closed generic type model you want, and maybe you want type arguments to be specified on the generic context. This was hard to support in the same exact easy way as above. To support this, you must manually define the read-only dictionary property using the generic type parameters where you want them to be. Once generated, it will stick this into the interface, so it'll still be there for the interface, but it won't generate a property here, although it will load it properly. As you can see, the generic types are loaded. But another thing that was tricky was that referencing the generic context required that the serializable foreign key supported models that were generated must also be generic. They must carry the generic type arguments of the data context, otherwise you cannot access the appropriate data context for the foreign key references. As you can see, it looks quite similar except for this this generic type parameter, but it works. And generic contexts work too, which is really great feature to have. If we want to take a look at what actually happens and how this library works, we can take a look at the protobuf implementation real quick that I used, or that I created and wanted to use first, but you could use anything. Hang on, why can't I open this in Explorer? Oh, here we go. Let's take a look at the output of this, one of the tests, the generator test. You can see that you can actually choose the data source and the storage source. These are both different sources, so you can source the data from one location and source the data from a different location at load time. So in the case of this generator test, I source the data from an Entity Framework core DB context, and I generate protobuf files, and I write them to disk with the GGDBF extension. There are many ways that you could implement this, and in fact, it is agnostic. The core library is agnostic to the implementation. You just need to implement the interfaces, the data source interface and the writer interface, and you're golden. The writer interface will take in a serialization interface, and you can control all these if you really want to. But I think the most useful was Entity Framework paired with protobuf. Writing to file. There's other ways to do it, but this is the way I did it. And this basically, unless I find issues with it, makes the library nearly feature complete. More than feature complete. The support of a generic context was a really wishful thing to have, and I achieved it. So I'm going to publish this first version, and then I'm going to probably make a video that's going to use it, probably a Phantasy Star Online video, that'll actually show it being used in action, but you won't know GGDBF is being used. I might mention in the video, but it'll just work. It'll be used for static game content on the server side, and maybe one day the client side again too. So thanks for watching, guys. This will probably be the last GGDBF video, and I'll be posting a release to NuGet soon. Thanks for watching, and I'll see you in the next one.